I welcome all my dear students. Myself Nandini S, working as a lecturer in Mechanical Engineering Program, SJ Government Polytechnic, Bengaluru, Department of Collegiate and Technical Education. So this is the session 5 of Unit 1 Measuring Instruments. So in this session, we are discussing about errors in measuring instruments, types of errors in measuring instruments, and systematic errors. So first, what is an error? So this error is purely related to measuring instruments. Okay. So error is defined as the difference between true value and result. So true value means it is the actual value, exact value, and the result is nothing but the, so after measuring process, so whatever the final magnitude we get, so what are the final result we get, so that is the result here. Okay, after measuring process. So error is defined as the difference between true value and result. So coming to types of error in measurement system, mainly we have three types. So first one, systematic errors or fixed errors. So fixed error is the another name of systematic error. Second one, random errors or accidental errors. So accidental error is the other name of random error. So third one, illegitimate errors. Okay. So systematic errors. So this error is harmful in nature. Errors that occur in the measurement system regularly every time the measurement is made are called systematic errors. So it is repetitive and of fixed value. Fixed value means of fixed magnitude. Okay. So see, the systematic errors have definite magnitude and direction. The systematic error or fixed errors. So these are very harmful in nature. Okay. So why it is called fixed means until unless you find the error in the measurement system, you will not come to know. Okay. You need to check the instrument for errors, whether the instrument have any type of errors or not. You need to check that. Systematic error means, so you need, if you check the measuring instrument only, you will come to know whether the systematic error is there in the instrument or not. Otherwise, every time you do the measurement, there will occur. Okay. So it is repetitive and of fixed value. So every time while you do the measurement, so the error will repeat, and that error magnitude will be same. It is fixed. Okay, so the systematic errors will have definite magnitude and direction. Definite magnitude and direction means, for example, we have a vernier caliper which has -3 mm error. Okay, so after measurement, what we will do, we will add +3 mm to the results, right? Or in some formula. Okay, so we need to make the error correction there. Otherwise, we will get -3 mm error. Always when we do the measurement, so the instrument will give -3 mm error. We need to correct it. The first, what we need to do, we need to calibrate the measuring instrument. If we calibrate only, we will come to know whether the instrument has systematic error or not, and what is the magnitude of that error. Okay. So see, systematic errors or fixed errors are nothing but human error, calibration error, instrument error, stylus pressure, environmental errors. Okay. So coming to human error. So human error means, as the name, as the error itself, see, human error. So the errors caused by the human or the operator or a person who is taking measurements. So see, human errors. So human errors. So human error, the errors caused by the humans or operators or a person who is taking the measurements. So see, this human error is common in beginners. Common in beginners means, for example, uh, first sem student. When the first sem student is taking measurements using vernier caliper, so some errors may occur because he is a beginner, he is a learner, he is using the instrument for the first time. He is using the instrument for the first time, so they may do some mistakes and the human error may cause. Okay, and sometimes see this human error depends differs from one person to another person. Okay, sometimes the see, for example, when a human has some problem with his physical condition or mental condition, if he is not feeling well, if he has some tensions, he cannot take measurements accurately. He cannot involve accurately in taking the measurements. Okay, and the seer maybe due to misreading of instruments. So sometimes if the instrument show 3 mm, okay, if the instrument shows result as 3 mm, so if you read 3.1 mm, so that is the misreading of instruments. So next, incorrect adjustments. So before taking any measurements, we need to adjust the parts in the measuring instruments. Okay, there will be some procedure, so we need to follow that procedure to get the accurate readings. So every adjustment should be done before taking the measurements. So those are the incorrect adjustments. So next, computational errors. Computational errors means calculations, calculation errors. If though you take the measurements accurately, okay, though you take all precautions, all adjustments, and you take good readings from the accurate readings from the measuring instruments, if finally if you do the calculations wrong, so that is also comes under human error. Okay, so that is nothing but the computational or calculation errors. Okay, human error means what? The errors which is occurred by the humans. That's it. Okay, it may be misreading, it may be incorrect adjustment of the instruments. So calculation errors like that. So next, calibration error. See this calibration error, we need to find calibration error. So this is very important. If you don't find the calibration error, every time you do the measurement, it will occur. Okay. So what calibration is? So calibration is the process of checking the reliability of the instrument, right? Whether the instrument is giving the correct results or not. We are going to check the reliability of the instrument. How we can calibrate an instrument? So we can calibrate an instrument with the help of comparing the instrument with the standards. Okay, because the standard will have accurate units. Okay, it will have accurate measurement. So when we compare our measuring instrument with the standard or known input, so we'll get the error. Okay, so always after taking the measurements from the measuring instruments, so we can add or subtract the errors, so that magnitude will be considered. Error correction should be done. So that is nothing but the calibration error. See, human error, how we can eliminate this human error means, sometimes when we repeat the readings for 3 to 4 times and take the average, so uh, the error can be reduced. Okay, so that is the human error. Next, calibration error. Next, instrument error. Okay, instrument errors. So see, instrument, the error from the instruments or nothing but instrument errors. So these are the points comes under instrument errors. See, improper selection and poor maintenance of the instrument. Okay, improper selection and poor maintenance of the instrument. We need to select proper instruments and also we need to maintain with good environmental conditions. Okay, so then only the instrument will give accurate results. Next, mechanical friction and wear, backlash, yielding of supports. See, mechanical friction and wear. Instruments will have different components. Okay, different components. If there are some moving elements like links, like cams, like pen and pointer, pen or pointer and scale measuring instruments. So like that. So there will be some, whenever there is moving elements, there will be some friction. Okay, because when we use the instrument continuously, there will be some wear and tear, there will be some friction. Okay, that is also an instrument error. Backlash will occur when there are gears. Okay, due to gears only, we will have backlash errors. Next, yielding of supports. When you have some supports, some yielding or extension of the supports will take place. Next, pen or pointer drag. When the pointer is not showing the results or it is not moving correctly as per the input, that is also an instrument error. Hysteresis of elastic members due to aging. Okay, when the instrument has some elastic members like springs, like some tubes, Borden tubes. Okay, so the elastic members will show some errors. Okay, that is hysteresis of elastic members. Okay, because when we use the instruments regularly, there will be some extension of the elastic members. So when they expand more, it may not give the correct results. Okay. The next, assembly errors. Okay, assembly errors. So in assembly errors, so what are all the assembly errors? Say incorrect fitting of the scale 0 with respect to the actual 0 position of the pointer. Yes, when the pointer is not set correctly to the 0, 0 reading in the scale. Okay, see in some instruments we can see though we are not using the instrument, though we are not putting any load, though we are not giving any input to the instrument, the pointer will show some reading. Okay, it won't be on the 0 reading. It will move to 1 or 2. Okay. So see, before giving the input to the measuring system, so always in pointer and scale type display, always the pointer should be on the 0 reading. So if the assembly is not done correctly, if there is incorrect fitting of the pointer and scale attachment, so the instrument will give assembly errors. Okay. Next, non-uniform division of the scale. When the scale is not divided properly, that is also the instrument error. Bent or distorted pointers. If the pointer is very sharp, very sharp, so it will point the reading correctly on the scale. So we can take or we can read the readings accurately. Otherwise, it will be a problem. Okay, we cannot read the reading correctly. So these are all the instrument errors. Instrument errors means if the instrument has some inbuilt errors, okay, or due to aging or due to use of regular intervals, some parts may have some errors, wear and tear. So like this. So these are all instrument errors. Okay. So next, stylus pressure. So stylus pressure. So the simple example for stylus pressure is, so this is the V block. Always the round, the circular object will be placed on this V block for the support purpose. Okay. And in roundness testing experiment, I am giving an example to show the stylus pressure. So how we can explain about that? So see, this is the V block. So this is a circular object, the workpiece, and this workpiece is placed on this V block. And this is the dial indicator or dial gauge. Here we have a scale and pointer arrangement, and this is the stylus. The stylus is placed on this surface of this workpiece. Okay. So this arrangement is referred to the roundness test. Whether this workpiece has, whether the workpiece is has some circularity or not. Any irregularities is there on the surface, we are going to test. Roundness test. Okay. ಅಂದರೆ ಇದು ಕರೆಕ್ಟಾಗಿ ರೌಂಡ್ ಆಗಿದೆಯಾ ಇಲ್ವಾ ಅಂತ ಚೆಕ್ ಮಾಡ್ತೀವಿ. ಈ ಸರ್ಫೇಸ್ ಮೇಲೆ ಏನಾದರೂ ಇರ್ರೆಗ್ಯುಲಾರಿಟೀಸ್ ಇದೆಯಾ ಅಂತ ಚೆಕ್ ಮಾಡೋದಕ್ಕೆ ಸೊ ನಾವು ಇದನ್ನ ಈ ಅರೇಂಜ್ಮೆಂಟ್ನ ಮಾಡ್ಕೊಂಡಿರ್ತೀವಿ. ಓಕೆ. ಸೊ ಸ್ಟೈಲಸ್. ಸೊ ಸಿ, ದಿಸ್ ಇಸ್ ದ ಸ್ಟೈಲಸ್. See, always we should not give more pressure to the stylus while keeping the stylus on this workpiece. We need to keep the stylus slightly. The stylus should just touch the workpiece. Just touch the surface of the workpiece like this. We should not apply any force or more pressure on this stylus. Okay. If you apply more pressure on the stylus, you won't get the accurate readings. See, as you turn this object for some amount, if there are any irregularities on this surface, so the stylus will move up and down. So the pointer will indicate the readings. Okay. So initially we need to set this pointer to 0. This is the first step. Next, we need to move this object. We need to rotate this object slightly. We need to divide this object into some divisions. We need to move this circular object slightly. If there are any irregularities on the surface of this workpiece, the stylus will move up and down. In turn, we can see the readings with the help of this pointer and the scale arrangement. I mean to say that, see, we should not give any stylus pressure on this workpiece. Okay, ಜಾಸ್ತಿ ಪ್ರೆಸ್ ಮಾಡಿ ಇಡಬಾರ್ದು ಈ ಸ್ಟೈಲಸ್ನ. ಸೊ ನೀವು ಜಾಸ್ತಿ ಪ್ರೆಸ್ ಮಾಡಿಟ್ಟಾಗ ಏನಾಗುತ್ತೆ, ರೀಡಿಂಗ್ಸ್ ಕರೆಕ್ಟಾಗಿ ಬರೋದಿಲ್ಲ. ಓಕೆ, ಸೊ ಇದೂ ಒಂದು ಸಿಸ್ಟಮ್ಯಾಟಿಕ್ ಎರರ್. ಸೊ ನೆಕ್ಸ್ಟ್, environmental errors. Environmental errors. See, when we purchase an instrument from the laboratories, okay, when we purchase some instruments from the laboratories, they will provide manual for that instrument. So that manual will consist of technical specifications and the conditions in which the instrument should be maintained. Every features will be given in the manual. Okay, so always we need to maintain the instrument in that ambient conditions. Okay, they will specify. So this instrument should be maintained at 35 degrees Celsius, 28 degrees Celsius, like that. If you won't maintain the instrument in the given temperatures and pressures, it won't work properly at all. Okay, it won't work properly and it won't give the results. It won't give the reliable results, accurate results. So that's the reason why the manufacturer will give the entire technical specifications and some features related to the measuring instruments while purchasing the instruments. They will provide not only for the instruments. You can for example, calculators, any TV, television, so anything, they will provide the specifications. Okay, so always see, the instrument depends upon the environment also. See, why we preserve the primary standards in national physical laboratories? So this is the reason, to preserve the unit of that standard. Always the primary standards will be kept in national physical laboratories under good environmental conditions, good ambient conditions. The temperature will be maintained, the pressure will be maintained, there will be good cleanness. Okay, cleanliness will be there. Okay, the AC will be provided, no dust, so like that. So they preserve the unit of the standards. Okay, so like that. So see, the environmental errors. So the for example, see, change in the temperature may alter the elastic constant of spring. So spring elastic constant can change if you change the temperature of the instrument, and change in the dimensions of a measuring element or linkage in the system. So when the temperature changes, the dimensions also changes. It may expand or it may contract, like that. Okay, if the element or linkage is made up of metals, what happens when you maintain that measuring instrument in higher temperature? Sometimes it may melt, it may expand. So when it expands, obviously the parts won't work properly and you get errors in that. Okay, so may alter the resistance values and flux densities of magnetic elements. Okay, see, not only temperature, if there is some changes in pressure, humidity, okay, humidity, altitude, so like that. So always we need to maintain measuring instruments with good ambient conditions, good environmental conditions. Okay, so if you won't maintain, obviously we will get the errors. So this is about systematic errors or fixed errors. Okay. So in this session we discussed error. The definition of error is the difference between true value and result. So this is related to measuring instrument. Types of errors in measurement system: systematic errors or fixed errors, random errors or accidental errors, illegitimate errors. Systematic errors are also called as fixed errors, and this error is harmful in nature. So the errors that occur in the measurement system regularly every time the measurement is made. Okay, and it is repetitive. Whenever you do the measurement, so the error will be repetitive and is of fixed value. For example, I told 3 mm. When you use the vernier caliper, if it has 3 mm error, always after taking the measurements, you need to add 3 mm plus 3 mm. Otherwise, you will get the error. Okay. It has a definite magnitude. Definite magnitude means see like 3 mm. So always you need to make error corrections. And direction means always it will be less. So sometimes it may be high. Okay. Sometimes the vernier caliper, for example, it has plus 3 mm error. Then after measurements, you need to make it as minus 3 mm. Okay. So like that. Unless you find the error in measuring system, you would won't know about the systematic errors. ನೀವು ಎರರ್ ಸಿಸ್ಟಮ್ಯಾಟಿಕ್ ಎರರ್ ಇದೆಯಾ ಇಲ್ವಾ ಅಂತ ಫಸ್ಟ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸೊ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀರಾ? ಕ್ಯಾಲಿಬ್ರೇಷನ್ ಮಾಡೋದ್ರಿಂದ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. ನೀವು ಕ್ಯಾಲಿಬ್ರೇಷನ್ ಮಾಡಿದಾಗಲೇ ಗೊತ್ತಾಗೋದು ಅದು ಸಿಸ್ಟಮ್ಯಾಟಿಕ್ ಎರರ್ ಇದೆಯಾ ಇಲ್ವಾ ಅಂತ. ಸೊ ಅಲ್ಲಿ ತನಕ ನಿಮಗೆ ಗೊತ್ತಾಗೋದಿಲ್ಲ. See, systematic errors or fixed errors. So here you have human error, calibration error, instrument errors, stylus pressure, environmental errors, etc. Okay, etc. Not only this, etc. There are many. Human error means it is caused by the human. Okay, so it may be misreading of instruments, incorrect adjustments, computational errors, that is calibration errors, and this is common in beginners. ಲರ್ನರ್ಸ್ ಅಲ್ಲಿ ಕಾಮನ್ ಆಗಿರುತ್ತೆ ಹ್ಯೂಮನ್ ಎರರ್ಸ್ ಮಾಡೋದು ಸಹಜ. ಓಕೆ, ಸೊ ಅದನ್ನ ಕರೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋದೆ ಇರೋದು. ಸೊ ನೆಕ್ಸ್ಟ್ calibration error. So calibration error means in the calibration we need to calibrate the instrument, okay, in the regular period of time intervals like monthly, yearly, like that. So then only we will come to know the error in the instruments. Otherwise, we will get the fixed error. Next, instrument errors. So, improper selection, poor maintenance of the instrument, and mechanical friction and wear, backlash, and hysteresis. Coming to the assembly errors, so incorrect fitting of the scale 0 with the 0 position of the pointer, and a non-uniform division of the scale. So scale readings irutte alva, ಆ ರೀಡಿಂಗ್ಸ್ ಎಲ್ಲ ಕರೆಕ್ಟಾಗಿ ಡಿವಿಷನ್ ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೂ ಅದು ಒಂದು ಎರರ್. ನೆಕ್ಸ್ಟ್, ಬೆಂಟ್ ಆರ್ ಡಿಸ್ಟಾರ್ಟೆಡ್ ಪಾಯಿಂಟರ್ಸ್ ಕರೆಕ್ಟಾಗಿ ಇಲ್ಲ ಅಂದ್ರೂ ನಮಗೆ ಎರರ್ ಬರುತ್ತೆ. ಯಾಕಂದರೆ ಪಾಯಿಂಟರ್ ಆ್ಯಂಡ್ ಸ್ಕೇಲಲ್ಲಿ ಅಬ್ಸರ್ವರ್ ಕರೆಕ್ಟಾಗಿ ನೋಡಬೇಕು. ಪಾಯಿಂಟರ್ ಆ್ಯಂಡ್ ಸ್ಕೇಲಲ್ಲಿ ಕರೆಕ್ಟಾಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಕರೆಕ್ಟಾಗಿ ನಿಮಗೆ ಗೊತ್ತಾಗೋದು ರೀಡಿಂಗು, ಇಲ್ಲಾಂದರೆ ಗೊತ್ತಾಗೋದಿಲ್ಲ. ಡಿಜಿಟಲಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಜಸ್ಟ್ ಹಾಗೆ ತೋರಿಸುತ್ತೆ ನಂಬರ್ಸ್, ಬಟ್ ಇದರಲ್ಲಿ ರೀಡಿಂಗ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಪಾಯಿಂಟರ್ ಆ್ಯಂಡ್ ಸ್ಕೇಲ್ ಮೆಷರಿಂಗ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸಲ್ಲಿ ಟೇಕಿಂಗ್ ದಿ ರಿಸಲ್ಟ್ಸ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. Coming to environmental errors, so in changes in temperature, pressure, velocity, humidity, will change the dimensions of the measuring elements in the measuring system. So this may also give the errors. Okay, so we need to maintain the measuring instruments in ambient conditions specified by the manufacturer. So stylus pressure is nothing but we should not apply the pressure, the stylus pressure while taking the readings. So on this workpiece. Okay. Not only this workpiece, when we are using some instruments or devices which is having the stylus, we should not apply more pressure. It won't give the readings correctly. So here are the reference books. So for your syllabus, the mechanical engineering measurements by Thomas Beckwith, the reference books Mechanical Engineering Measurements by A.K. Swane, Metrology and Measurement by Anand K. Beur. So there are many books. So Principles of Engineering Metrology by Rajendra and Dimensional Metrology by Connie Dodson and Engineering Metrology by R.K. Jain. Okay.